This is the first session of Chapter 3, Computer Organization. So recall the block diagram of a computer. The CPU has three parts: control unit, arithmetic logic unit, and internal memory. Internal memory is also called registers. The CPU communicates with the other components through bus. What is a bus? A bus is a collection of wires used to communicate between the internal components of a computer. There are three types of bus: control bus, address bus, and data bus. Note that control bus and address bus are unidirectional. The data bus is bidirectional. The CPU has the following registers: MDR, MAR, and PC. Memory data register stores the data which is transferred between memory and CPU. The memory address register stores the address of the data to be fetched from memory. The program counter is a special register which stores the address of the next instruction to be executed. First, we will see how a memory read operation takes place. Read operation transfers data from memory to MDR. During a read operation, the ALU places the address of the word to be fetched from the main memory in the memory address register. The control unit sends a read signal 1 to the main memory through the control bus. The address of the word to be fetched is transferred from memory address register to the main memory through the address bus. A decoder circuit is a digital circuit which points to the specific memory location where the word can be located. The word is then transferred from main memory to memory data register through the data bus. Next, we will see the write operation. Write operation transfers data from MDR to memory. The control unit sends a write signal 0 to the main memory through the control bus. The address of the word to be written is transferred from memory address register to the main memory through the address bus. The word is then transferred from memory data register to the main memory through the data bus. In between the CPU and main memory, there is another high-speed memory called cache memory. The cache memory is a very high-speed and expensive memory that stores frequently accessed data. This helps to achieve fast response time of the main memory. Response time or access time refers to how quickly the memory can respond to a read or write request. The major components of the CPU are housed in a single chip integrated circuit called microprocessor. The performance of the microprocessor depends on the following characteristics. Clock speed, instruction set, word size. These are the characteristics of microprocessor. Clock speed. The speed at which the microprocessor executes instructions is called clock speed. Clock speed is measured in MegaHertz or GigaHertz. Instruction set. The basic set of machine-level instructions that the microprocessor is designed to execute is called instruction set. Word size. The number of bits that can be processed by the microprocessor in a single instruction is called its word size. Microprocessors are classified based on word length, that is word size, and instruction set. The classification of microprocessors on word length are 8-bit microprocessor, 16-bit microprocessor, 32-bit microprocessor, and 64-bit microprocessor. Based on instruction set, the microprocessors are classified into reduced instruction set computers, complex instruction set computers. Reduced instruction set computers have a small set of highly optimized instructions. Complex instruction set computers support hundreds of instructions. Here are some examples of reduced instruction set computers. Pentium 4, Intel P5, AMD K6 and K7. Examples of complex instruction set computers are Intel 386 and 486, Pentium 2 and 3, Motorola 68000. The contents of memory can be accessed by two methods: sequential access and random access. In sequential access, the contents are accessed in an orderly manner from start to end. In random access, any byte can be accessed directly without navigating through previous bytes. Memory devices, RAM and ROM. RAM, random access memory. It is volatile in nature. When the computer is switched off, its contents are erased. Types of RAM are DRAM and SRAM. DRAM stands for dynamic RAM. SRAM is static RAM. DRAM needs to be refreshed often, whereas SRAM needs to be refreshed less often. ROM, read-only memory. It is non-volatile in nature. Its contents remain permanent even when the computer is switched off. The contents are stored during manufacturing itself. ROM stores critical programs that boot the computer. Types of ROM: PROM, EPROM, EEPROM. As we have seen, ROM is itself non-volatile, then all its types are also non-volatile. PROM, Programmable Read-Only Memory. The contents can be written only once and cannot be erased. The contents are stored in PROM using PROM programmer or PROM burner. EPROM, Erasable Programmable Read-Only Memory. Contents can be erased and reprogrammed using ultraviolet rays. EEPROM, Electrically Erasable Programmable Read-Only Memory. The contents can be erased and reprogrammed using electrical charge. Thank you.